welcome to this tutorial. In this tutorial we're going to explore the question, why binary? Now, we know that computer systems, ultimately when your programs are compiled and they're running, all they're doing is they're processing a series of zeros and ones. They can be millions and millions of zeros and ones together, but all they are zeros and ones. Now, so if we ask the question, well, why? Why don't we use fives in a computer system? So we have a first column that says 5, the next column that says 6, and so on. Well, we don't do that because computer systems, down at the very basic level, are just pieces of hardware. Yeah, they're physical objects, and these physical objects, or these artifacts, are controlled by transistors, and transistors only have one of two values. They are either 0 or they're 1. Yep, there can't be a 2, because we know if it's 2, then we have to add another digit in. Yep, so let's have a look at a binary system. There we go, just going to drag this up into the space. There we are. Now, what we're looking at on the screen is a nibble. Now, our nibble is represented by the 4 switches at the top, so that switch, that switch, that switch, and that switch represents 4 bits, or as it's commonly called in computer science, a nibble. Okay, and just like in our number system, our normal number system, we have a units column and a tens column and a hundreds columns and 1,000 column and so on. Remember, in binary we have a ones column or units column, a twos column, a 4 column, an 8 column, a 16, a 32, a 64, 128, 256 and so on. But we're working at a small level here. So how does this very simple zeros and ones or on and off system control what's going on a computer? Well, if we think about an electronic calculator, which is just a computer system, it's a very simple one, and most electronic calculators have what is called a 7-segment display, and they have a series of them. If we look at our screen, well, I've just switched on the 8s column, or the 4th bit in our nibble, and we can see that the blue number 8 has actually got 7 segments, and so I need to be able to control all 7 segments to get a maximum value of 15, because remember, in nibble in binary, if you add all of the numbers up, if I add up 1, 2, 4 and 8, that comes to 15. Alright, so I need to be able to display 15 on my 7-segment display. And that might sound like a bit of a tall order, but let's start at the very beginning. Well, if I have a value of 1 in my units column, then what I'm displaying is 1. Likewise, if I have the 2's column switched on and all the others have a 0, so my binary number would be 0010, then my 7-segment display on my calculator is showing 2. I do the same with 4, there we go, so 0100, that would be 4, and my 8's column, well, 1000, that displays 8. Now that's all very well, and if I want to display the value 9, well, that's 1001 in binary. There we are, I've got the value of 9. But how do we get to beyond 9? Because we know that a nibble can actually display the values of 15. Well, I'm going to turn them all off for the moment, and we will cycle through them. So if I switch on that, and that gives us 3. Okay, we know that. Now I have 4, 2 and 1. Well, that gives us 7. And if I had put a value in the 8's column, yeah, so I've got the binary value 1111, we can see that what's actually happened is that our display has turned to F. Now F is the hexadecimal value for 15. Okay, so if we take that down, so if I switch off the 1, well, we can see that we've now got our binary value 1110, and that's E. If I turn off the 2's column, okay, so that's 1100C. Now C in hexadecimal is 12 in our number system. So if I turn on that value there, so we've got 8, 4 and 1. So that's D. It looks a bit like a backwards C, 6 rather, but it's actually a D if you think about it. It's lowercase d. So that's our hexadecimal value for that. Okay, and I'm just going to go to the value for 10. Whoops, switch on the 8's column and the 2's column, switch off the 1's column. There we are, A. Now 11 in hexadecimal is B. There we are, there's B. Okay, so simply by having 4 inputs, I can actually control my 7-segment display. I can get it to show the values up to 15, albeit it shows it in hexadecimal, but I could restrict it, of course, so that the maximum value that it's able to show is 9. Yeah, I could remove some of the switching so that I didn't have some connectors on them. So for example, if I didn't want to include the 8, if I just take that column out, there we are, and I just remove that altogether over there, then the maximum value I can display is 7. Yep, there we go. But I'm going to put that one back in because I quite like the idea of having a nibble that is able to represent a calculator using the 7-segment display module. Okay, so back to this question, why binary? Well, why binary? Because all computer systems run on binary, and binary has to be used because all computer systems use the physical component of a transistor, and a transistor only has the values of 0 and 1. And of course, that represents a couple of problems for computer scientists who design hardware, because they have to have ways of switching devices on and off that might have multiple states. And in this example, the multiple states that I could have are 16. 16 because, of course, if I have the value 0000 in binary, or 0, I need to be able to represent the value 0, and that is all of them off. And then if I add all of the positive numbers, if you like, from 1 to 15, there we go, just scroll through them. Yep, I've then got a method of telling my little component on the screen to display the value 15. And of course, it makes sense if you know hexadecimal. If you don't know hexadecimal, you wouldn't realize that. Okay, so remember the question, why binary? Why binary? Because computer systems are transistors, and transistors need to control sometimes very complicated pieces of equipment by switching the range of transistors on and off, sometimes in very rapid succession, to get different displays.